senior software developer. Today, I'd like to tell you a little story about a cowboy named Syntax Swift Code Slim. But that name only came much later in his life. Before that, he was simply known as Slim, a young boy with a glint in his eye and a restless spirit, who dreamt about the Wild West, tempted by wild lands, untamed lands, hidden riches, and adventures in the thrill of the unknown. It wasn't long until Slim set off into the wild. He packed his meager bag, slung his six-shooter over his hip, and set off into the Wild West. Every sunrise brought on a new spectacle, and every sunset was spent next to a campfire under a blanket of stars. He rode hard, he rode fast, and took shortcuts through canyons that nobody else dared. In a forgotten riverbed, he struck gold, finding riches far greater than anything he'd ever owned before in his life. He even escaped a stampede of raging bulls by cutting a fence and escaping through it. And even outsmarted a notorious bandit gang by scattering their supplies across the desert. Slim was fast, he was fearless, and every challenge felt like another tale to tell, another tale to add to his legend. Life was essentially a thrilling, chaotic dance, and Slim felt invincible. He was building his legend one daring decision at a time. But the Wild West, like any wild beast, eventually demands its payment. Those shortcuts he had taken only led him into unknown territories far from any familiar trail. The shortcuts that he had cut through the fences only led to his horses escaping with all of his supplies. And the gold that he had found, he'd spend just as quickly as he had found it, never truly investing it in any reliable maps or reliable gear. And then finally came the town of Redemption Ridge. Slim walked in, confident as ever. But what he found inside was the notorious bandit gang he had once outsmarted. They remembered him, and they were furious. It wasn't long until this tense standoff erupted into pure, unadulterated chaos. Gunshots ripped through the air, splinters flew, and the dust choked the very light from the sky. He took a bullet to the chest, and then another. And the searing pain served as nothing but a stark reminder of every shortcut, every unmended fence, every decision he had made. And as he laid there, staring into the darkening sky, with the very real prospect of losing his life, his legend, his future, all because he had ridden too fast, too loose, too recklessly. But I'm sure you're probably wondering what this little story about a cowboy has to do with us as software developers. Well, if you think about it, there's a lot more in common than you think. Because in the thrilling, chaotic world of software, we all have a little bit of Syntax Slim in us. When we start a new feature or a new project, or perhaps even join a new company, there's that initial rush, that yearning for adventure. We're excited for the new challenge and the freedom that we could have and the speed at which we could build everything. And just like Slim, we're cutting through code, integrating fancy APIs, building amazing new features, and it feels absolutely invigorating. Every quick deployment, every successful deployment that we make, every quick iteration feels like a win, another victory to add to our developer belt. We're pushing features faster than the competition. We're seeing immediate impact, and this feels absolutely invigorating. But just like Slim's unmended fences and unmapped territories, this lightning fast development speed driven by largely the cowboy mentality also comes with its own unseen costs. Those quick fixes that we made to get a feature out the door, a temporary workaround to a database integration, or perhaps even a function that we copied and pasted without ever truly abstracting it or rewriting it properly. These are essentially our unmanned defenses. And this also quickly develops into what we call a feature request avalanche, an exciting flood of new possibilities. But it also can quickly transform into a suffocating pile of work that needs to be done. And then eventually the chickens come home to roost. A critical bug from poorly tested and quickly implemented feature emerges. A simple change to the project requires refactoring half the application, all because of spaghetti code. Technical debt piles up, and performance grinds to a halt. Team burnout sets in. And then we find ourselves in our own little gunfire fight at Redemption Ridge, a chaotic, desperate scramble to fix a mountain of bugs, untangle a web of inconsistencies, and firefight issues that could have been avoided. And just like Slim almost lost his life, we risk losing our product, our users, all because we valued unchecked speed over sustainable growth. My journey through the startup world has taught me many things. Largely that building solutions fast and delivering at breakneck speeds can teach you many lessons, and many lessons the hard way. I've been slim. I've been riding hard, been riding fast and free, and I've felt the sting of these consequences. Which is why my talk today isn't just about shying away from speed. It's about learning to make smart decisions when every second counts. I've been a developer for about 9 years now, been building software and solutions for many clients. Currently, I work for a small agriculture company where we essentially build tech solutions for farmers. But I'm fairly new to the startup world. I've only just recently started exploring this side of my career. For most of my career, I've worked for very large organizations that had very structured and organized way of working. Everything from essential rules and regulations about how to design, architect, and structure your code, as well as how to test and deploy it. They had very large teams that were dedicated to automation, to database administration, and the various other elements of the software development ecosystem. And currently, I am part of a team that is comprised of mainly senior developers, much like myself. So you can imagine just how excited when I initially joined this elite team. I was so excited that you could swear I was a 2-year-old who just discovered ice cream. But because of our team's very small size, we also have to wear many different hats at the same time. Everything from DevOps to security, architecture, and even database administration. We are primarily developers, yes, but depending on the problem at hand, we may have to put on a different hat, or if you are unfortunate, multiple at the same time. But having had joined this team, I discovered that I had quite a lot of freedom to do, well, more or less anything that I wanted. So I was riding hard and I was riding fast. The first feature that I implemented was implemented with the very same kind of energy, guns blazing without a care, breaking and fixing as I went. But instead of an epic tale of how I built this amazing feature at lightning speed, I instead got a tale about how I ran into a mountain of bugs and technical debt. So I started documenting my journey, started documenting everything from their infrastructures and everything on ideas that I could improve, including HLDs, automation flows, analyzing their security practices, database structures, and pretty much anything that I could get my hands on. But the more I questioned and discussed many of these ideas with my colleagues, the more I realized just how I didn't have enough hands to actually implement most of them. Because of our team's small size, we largely operate on very simple rules. Chief amongst them being if you have an idea, then you are responsible for implementing it. So my biggest problem wasn't a lack of ideas, or as a matter of fact, it wasn't even a lack of buy-in from my team members. I just didn't know how to implement these ideas without setting our entire infrastructure on fire. And that is exactly what would happen if I ran in guns blazing without a care. I would simply end up like a poor cowboy slim. But this also left me quite puzzled. I had deadlines to meet, features to build, bugs to fix. Where was I to find the time to actually implement any of these ideas? But my little adventure did also teach me something, that building fast comes with its risks, chief amongst them being bugs and stability. Things will break, they will definitely break, and you would be expected to fix them faster than you broke them. But this is part of the process. We essentially need to learn to make smart decisions when every second counts. We often think of cowboys as these reckless figures charging in headfirst without a plan. But I've learned that it is also quite important to be able to distinguish between the two types of cowboys, one being a reckless renegade and the other being a resourceful maverick. The resourceful maverick is essentially an innovator. They use what is available to them to get the job done efficiently and quickly. They're essentially masters of efficiency. They build solutions that fit the immediate need. This is the positive side of cowboy coding. The focus on delivery that allows us to outpace even the competition. On the other hand, the renegade is the developer who essentially cuts corners not out of resourcefulness, but instead out of haste. They essentially build features, move on, leaving behind them a trail of unmended fences and broken code. They fail to consider the long-term impact of the changes that they've made. And as a result, this approach can give you a lot of speed in the short term, but it will also leave you with a very brittle system that can collapse at any moment, much like a house of cards. So for example, you can think of a new client. Let's say you get a new client that wants you to essentially use a new payment gateway, a local option, and the actual full solution to integrate this new payment option would probably take weeks. The Maverick would try to find a third-party solution, which they would use as an API wrapper in order to quickly implement that solution. They would deploy this temporary solution into production, unblocking the team getting a sale and allowing business to essentially validate the feature. And then they would go back and essentially take note of it, create a new ticket in order to essentially come back and create a more robust solution. This shows that they are thinking about the future while prioritizing the immediate business need. On the other hand, the renegade would hard code API keys and URLs. They would bypass security and testing protocols. And then when a new client comes along, they would simply just copy and paste the same code, leaving behind them a tangled mess of vulnerabilities and inconsistencies. And then as soon as the API keys expire, there would be a huge scramble to try and figure out what went wrong, all because nobody actually knows what the problem is. So as developers, I believe we should aim to be more like the Maverick, not so much like the Renegade. But then the second lesson that I've learned is that you need to understand that speed comes with its own costs, one that are usually hidden and aren't seen right away. we may take shortcuts when we're essentially working, but the cost of those shortcuts is usually hidden until it all comes crashing down at once. This is what we usually call technical debt. The quick fixes and the inconsistent code structures, that these are all essentially just debt that we're taking on. We initially get the benefit of speed, but that debt also becomes quickly unmanageable. And you can usually see this in, usually it manifests itself in one of three ways, either as code inconsistencies, team burnout, or perhaps even scalability issues. With code inconsistencies, you'll notice that the project feels more like a tangled wilderness, where you may even feel like you're investigating homicide, but the only catch is you are also the culprit. Then with team burnout, what you essentially experience is that with the relentless pace and the constant firefighting, the bug fixing, trying to deal with just technical debt, it weighs a very heavy toll on the team. This is mainly because a project that has a lot of technical debt usually requires a lot more mental energy to try to make simple changes without breaking any of the existing functionality. And then lastly, with scalability issues, you may notice that the quick fixes that we made for a few users may have worked perfectly fine, but then as soon as you scale to thousands or perhaps even tens of thousands of users, the system now starts to fail. And those would either show as or manifest as the system either responding a bit too slowly or even crashing altogether. So how do we actually write fast and without crashing and burning? The simple answer is, well, the simple answer isn't to actually slow down, but instead to try to develop a more sustainable growth or sustainable sprint mindset. You can think of it much like trying to run a marathon. So, and I would like to offer you about 3 tips in terms of how you can try to achieve a bit more speed. The first being ruthless prioritization. Secondly, you need to be able to smartly manage your technical debt. And then third, you need to implement some form of selective automation. With ruthless prioritization, it essentially involves the simple fact of accepting that you can't build everything at breakneck speeds. So what you need to do is that you need to learn to identify which features are critical and require a solid foundation, and which are more experimental, where a data quicker approach to it may be acceptable. Then secondly, technical debt is also inevitable, but that doesn't mean that it has to be a death sentence. In order to better manage it better, you can treat it more like a manageable chore instead of a crisis. And you can do this by trying to spend a bit of time each sprint to trying to tackle some of this technical debt. With selective automation, you essentially need to be able to identify which tasks are more repetitive, and then you essentially just automate those specific tasks, especially tasks that could lead to either team burnout or a lot of errors should mistakes happen. So you need to try to use the resources that you have available to you to automate key parts of your workflow. This can be, for example, the deployment pipeline or some code quality checks and testing. But the essence here is that in order to survive in a fast-paced environment, you need to be smart, not just fast. It's about building a system that allows you to be fast. And I'd like to offer you, I guess, a few more practical lessons in terms of how you can actually achieve the speed. Well, firstly, when it comes to smartly managing your technical debt, you need to treat your project or code base much like a wrench, where shortcuts are equivalent to fences being left unmended. So you need to manage them in order to avoid it becoming risky or an unnavigatable mess. And one way to better manage technical debt is to try to implement a kind of technical debt tax, where you spend a bit of time each sprint, which could be either a day or perhaps even an hour in a day, to trying to clean up some of your technical debt. But then you could also try to implement a bug bounty board, where you make the technical debt visible. This transforms it from a vague looming problem to a more manageable list of tasks that need to be done. And lastly, my personal favorite is to essentially just fix as you go, where you empower the developers in your team to try to make improvements as they're working on any feature that they're trying to build. This, for example, if you're in a file and you notice some glaring inconsistencies, you can spend a bit of time to essentially try to clean it up and perhaps even abstract some of the logic away. But the idea is to essentially leave the campsite better than you found it. Then when you try to leverage selective automation, in the Wild West, a good tool can save your life. In software, automation is that tool. But you need to note that you don't need to automate everything. You just need to automate and essentially focus on the few things that can add value to what you're doing. So a good rule of thumb is to essentially automate your pain points. So identify the common sources of pain for your team and errors, then essentially try to automate these parts as a way to, I guess, streamline your workflow. Then another form of automation is actually making use of third-party APIs. So if you're gonna need some kind of maps in your system, it might be a lot quicker to try to integrate with Google Maps instead of trying to launch your own satellites into space. And then finally is to essentially try to foster a more open knowledge culture in your company amongst your developers. So whenever something goes wrong, we should ideally try to avoid playing the blame game, which is essentially pointing out fingers at whoever may have caused the issues, which can be a bit chaotic. Instead, whenever something goes wrong, try to perform a blameless post-mortem, which involves the team essentially just focusing on what caused the problem or what decisions led to it. Then you could also try to create some informal opportunities where team members can share their knowledge. This could be either over a nice cold beer or perhaps even a game of pool. And then lastly, you need to celebrate smart decisions and not just quick deliveries. This involves recognizing and giving credit to developers that spend a bit of time to clean up the code or abstract a very confusing part of the system. So to sum it all up, my journey through so essentially being a cowboy has taught me many things. But chief amongst them is that the Wild West can offer you a lot of freedom. But this freedom doesn't mean ignoring all the rules and doing whatever you want. It means creating new rules that allow you to build a system and software that you can be proud of. Thank you. Okay, I think we can move on to questions. Yeah. Okay, doesn't seem like there's any. Okay, I think there's one back there.
So you've mentioned automation and using automation. Do you have some examples of where automation would work in a system, and what type of tools do you use for that?
Okay, I think the easiest would essentially be deployments. So I think that would depend on what you're essentially running your production environment in. So if it's just simply just running a simple application on a server, then you can write bash scripts and then just integrate that into, I guess, whatever version control system that you're using. So every time you kind of merge into a specific branch, then it just triggers deployment, I guess doing all the tests that you're looking for, and then just deploying that into production. But yeah, it's largely dependent on, I think, whatever you're using to run your production system. Okay, there's another hand.
Hi, Seale. Thanks so much for the talk. Very insightful. There's this saying that says, in order for you to know that you're very, very stupid, you have to be relatively intelligent to know that you're stupid, because you have to have a form of intelligence to identify the things you're stupid at. So we generally work with different tech stacks, and
Yeah.
most of the time we're just exposed to one, and you might move to a new project or something like that, and it's very different. Example, you're in front end, you've been so familiar with React, and you move to Angular. How do you develop the neck as a full stack, for example, to identify those little areas where it's problem areas? It's already been built, the code base exists, and let's assume it's a mess. How do you go about unwrangling all of that to understand that there is actually a problem in things you haven't worked with before?
Okay, I think the biggest telltale is essentially just listen to what the other devs you're working with are complaining about, because that's usually where like those pain points would be. So if it's something, I guess either the deployments are a bit too stressful, because I mean every time, let's say they deploy and you can see that they're visibly stressed, then it means that probably there's something in that flow that can be fixed. So I guess that's basically the telltale. Just try to look at what they complain about the most, because that's usually where the problem is. Okay, I think there's another question in front here.
Hello, Seale.
Hi.
So you mentioned a lot of points on improving code and actually like catering for the quality in terms of the quantity of the code. So what would your advice be if, let's say, someone is in a situation where the client code is very old and we are migrating stock messages to Java Spring, for example. But then when we now deploy these new changes with the improved code, like also like the production environment can't really handle like the new improvements. So
Okay.
like would we have to just continue building on top of the bad code, or we at least find a way to like make the production environment stable to cater for the new code that's much better?
Okay, so well, ideally we would want to write new code that's better than the old.
Yeah.
But that's not always feasible. I think especially with like legacy systems, it can be that the code has just been like so old that I guess like it's a bit difficult to kind of I guess like refactor and put in a new implementation. But the key thing, I think, like in terms of like just making your code a bit more readable, it's just finding like just I guess try to standardize it. You don't need to build something new. As long as everything is kind of standardized and it's easy to read, then that should solve a bit of the problem.
Okay, makes sense. Thank you.
Hi. Okay, so
Hi.
I think maybe it expands on the previous question.
Okay.
How do you determine the threshold to say that this now like we would have to go. Like, let's say if we're at a crossroads,
Mhm.
I came up with like an idea that I'm thinking we can refactor this into something good,
Mhm.
but then there's the possibility that we will hit a brick wall going in that direction where a rewrite would have been better.
As in a rewrite of the entire application.
Yeah, something like that. So like where do you draw these? Like how like are there any
Okay.
like good
Well,
rules of thumb?
I think the question is it feasible? Because I don't think business is gonna wait for you to spend 3 months or 6 months trying to rewrite the system that does the exact same thing. So if it is feasible, then sure, you would want to build something that is, I guess, better than what's already existing. But if not, I guess it's more like trying to figure out how you can make the best of what you currently have. Yeah, because at the end of the day, I think we are still kind of chasing after deadlines, trying to meet actual I guess like business requirements and all of that. So you kind of need to weigh where it fits in into all of that. Because the priority, unfortunately, does go with business. We usually just clean up the code to make it easier for us. So if you can clean it up, so if you can build something new, then build it. But otherwise, I think you might be better off trying to clean up what's currently there. Cool. And any other questions?
Oh, yeah. Hi, Seale.
Hi.
Right here in front of
Okay,
me.
sorry. The lights. My bad.
Okay, cool. You mentioned something about knowledge sharing.
Yeah.
That's a great culture. But as a junior dev, how would you advise someone to have the nerve to share knowledge with people that I'd assume know more than me, obviously?
Mm.
So it becomes a bit of a challenge to,
To share knowledge.
yeah, because you'd assume these people already know what am I talking about, right? But
Never
yesterday,
and never assume. I mean, I didn't expect this many questions. So
here we are now.
never assume. No, I think first start by asking, because I think like just asking, that's where the conversation kind of starts. And then as you find out more, then you'll actually start to see like, okay, I might actually have an idea about how this thing, or you can question the same. That let's say you ask about how they're doing something specific, then they will give you an answer. But then based on your experience, you might say that, okay, I think maybe we might be better off going in this direction. And then you tell them more about something like that. Yeah, but mainly just don't assume. I think just as you also want to know about something, it's very likely that they also want to learn about something as well. Cool. And any other questions? Cool. I think I'll take that as a no. Well, thank you.